Welcome children. How are you? Yeah. Last session in our 6th class science just discussed some basics about magnetism and how does magnet got its name. I hope you remember the story. Yeah, when I recall that story, I now just give you an assignment. After this session, in the homework also I'll add that, try to write that story in your own words. Okay? How Magnus went and how it was attracted, the wooden pole, everything. Okay, right? So we also discussed in the last session how some materials can be turned as magnets, so-called magnetic materials, and what are called non-magnetic materials, and what are the different shapes of magnets, where we use those magnets. These things we discussed in the last session. Right? Now, let us see some properties. How do we identify the effect, the power of a magnet? Okay. Now, let us see today's session's first activity. This is your activity 3 in the textbook. That's in page number 14. Separating iron fillings from soil. What you need to do is very simple. See, all this can be done if you have a bar magnet. Right? Simple thing is that collect some soil, sand, and put it in a tray, or directly you can go to the place where you have sand and just drop the bar magnet in the soil. That's it. Drop it and cover it completely with soil. Okay, just wait for some time. Don't do anything else. Okay, after some time, when we pick the bar magnet out of soil, some dark colored small pieces will be attracted to bar magnet. We wonder, what are they? Right? Generally, if you think about it, sand particles are not attracted by bar magnet. Then, when you dropped it into the soil, what are those which are attracted by bar magnet? Those are iron fillings. So, we cannot see them directly. There are some small, very small sized iron fillings. Those are all attracted by bar magnet. Okay. So, what does it confirm? Magnet can attract iron fillings even if it is mixed with some other materials which are non-magnetic. Okay. The sand and other particles, paper, dust, plastic cover, something, those are all non-magnetic. Even though these iron fillings are mixed with them, magnet attracted only iron fillings. That shows magnet can attract iron fillings. So this is how we can separate iron fillings from soil. Okay. Now, after doing this activity, if you observe carefully the bar magnet, there is one more interesting and special thing happened. You know what is it? Like this, there will be iron fillings attracted more, rather gathered more at two ends of the bar magnet, at two edges of the bar magnet. Okay, and look at the mid portion of the bar magnet. There also we see some iron fillings, but not as many as attracted at the poles. Okay, so we can say that the power of attraction of magnet is highest at its extremes, in the sense at its ends. When you come to the middle portion, the power of attraction is less than that of the power at the ends. Okay. these end portions where we find much power of attraction of a bar magnet, they are called poles of a magnet. What they are called? Poles of a magnet. This activity you can just do even taking a white paper, sprinkle some iron fillings above the paper randomly, then take a bar magnet, keep it below the paper. You just sprinkle the iron fillings above the paper, right? Now, keep the bar magnet below the paper. Okay, just move it. What should you move? Not the paper, bar magnet. Then, when you move the bar magnet, this effect can be observed. So that confirms the attractional power of a magnet is highest at its poles than at its mid portion. Okay, that's why we call it as pole strength. Strength, its power. Where is it? It is at poles. That's why we call it as pole strength. Okay, now it's confirmed that magnet has greater attraction at its end points. This can be concluded by activity doing with this paper, iron fillings and bar magnet. This is your activity 4. Right? Now, let us find the directions using a magnet. Actually, now just I told it has 2 poles, right? What poles they are? When you look at globe, Earth also has 2 poles, North Pole and South Pole. Like that, magnet also now got 2 poles. Okay, I just wrote here N and S. N stands for north, S stands for south. How and why it is named as north and south? Why not they are east and west? Let us see that. Let us observe the directional property of a bar magnet. Okay, let us do an activity. This is activity 5 in the textbook lesson. All you need to do is, once again, you need a bar magnet. Just tie it to a thread, hang it, it's called suspending. Freely hang it from a stand. What happens? Magnet moves here and there, left and right, front and back. Let it move, no problem. After all the movements is over, just observe how the bar magnet is going to stop. How in the sense, towards what direction it is pointing. Right? If you observe, I hope you know how to identify east, west, north, south. Just stand facing sun, that is east, left is north, right is south, behind is west. Now, just you stand how bar magnet settled. You can observe that this bar magnet also settles showing north and south directions of Earth. Is it final? You may have a doubt. Do one thing, move it, shake it, leave it, just wait for some time. Then after it stops all its movement, have a look at it. What happened? Once again, it settles pointing towards north and south. Okay, mark them with some marker or something and name the pole which is pointed towards north pole of Earth as north pole of bar magnet and which is pointed towards south pole of Earth as south pole of bar magnet. In general, they won't write N and S generally in a bar magnet when we purchase. We can observe a white colored dot at one end of the bar magnet. That confirms north pole. Remember, white dot represents north pole. So that shows the directional property. So magnet has 2 poles and the 2 poles are north and south pole. Okay, now coming to compass. You know compass. It's a round shaped case in which a magnetic needle made of aluminium is placed. Generally towards the north pole, it's made with a red color for our identification. This is used for what? To know the directions. Right? Generally sailors and water, they don't have any boards of directions left and right like on the roads. So they use this compass to identify north and south directions. Where it points towards north, red color, and other will be south, then east and west are also identified. Okay. Now, that is how we use a magnetic compass. Now, look at this. Look here. Now we are coming to another very interesting property of a magnet, that is attraction and repulsion forces. See, we just came to a conclusion that a magnet has two poles. What are they? North and south poles. Okay. Now, take two bar magnets and face two north poles or face two south poles together. What will happen, you know? They repel. You can feel something is pushing them. Okay? Something is pushing them. Okay? When both south poles are facing, or when both north poles are facing, like similar poles, I told here, what happens, you know, as I mentioned, they repel. Repel in the sense they don't attract. Some force is making them go away. That's called repulsion. Okay? Similar poles always repel each other. Right? Next, take the same two bar magnet. Let us face one bar magnet's north pole facing towards south pole of other bar magnet. So now opposite poles are facing together. Right? When opposite poles are facing together, immediately they will be attracted together. So that confirms that similar poles repel and opposite poles attract. This is the force of attraction and repulsion between the poles of a magnet. Okay, so in this session, we discussed how to separate iron fillings from soil and how to identify poles of a bar magnet, where we find more strength of a bar magnet, how to find the directions of bar magnet, how to use compass, and it's also about the action of bar magnet when similar poles are faced and opposite poles are faced. Okay, so you have all this in the textbook from activity 3 to 6. Go through all those activity. As I mentioned at the beginning of the video, try to write the story of that Magnus. Okay, right? I hope you are staying at home. Stay home, stay safe. Thank you.